Okay, so welcome back. Hopefully you've had some time to come up to speed on using Python, or you have some previous programming experience that you're going to use to apply to this exercise. So let's get ready to get our hands dirty. Before we dive into getting into this problem and doing something with machine learning, I've listed two articles here, a day 0 intro to machine learning and a day 1 intro to machine learning. Take just about 10 minutes, 15 minutes and read through both of these. They are sequential articles and they're going to help you really supplement what you're doing in this particular exercise. So while we're here, let's go ahead and dive into one of the two things that I told you in the previous video would be the most difficult parts of machine learning. The first one is actually defining and deconstructing a business problem. Believe it or not, this is really difficult. It's hard for most people to apply machine learning to an everyday business problem and get business value out of it. I meet with Fortune 500 and Fortune 100 companies all the time that tell me, Ben, I don't know how to use AI, or I don't know how to use ML. How do I get business value out of this? So we're going to look at a mock scenario and we're going to pull it apart before we get started so you know exactly what you're going to be doing with machine learning. And then we're going to dive into sort of converting that problem into inputs and outcomes. So I've built this mock scenario for you here that you can read through, and I'll read it for you. As a new data science or ML student, you've been tasked with building a new local climate model that climate scientists can use for predicting global horizontal irradiance. Basically, that's the amount of usable solar energy that comes from the sun. You've been provided with a historical set of actual weather data readings over 1 year. They come from a city called Athens, Georgia. Basically, this is a spreadsheet. It has 7 different columns in it. Those columns are time of day, temperature, humidity, dew point, barometric pressure, wind speed, and then the amount of solar radiation, right? These have 7 different columns and thousands of readings, so thousands and thousands of rows. So this is this historical data set that we've been provided with. Now our task, what we've been asked to do, is we need to use something called supervised learning, which we'll dive into in the next video, to build a new model that's at least 70% quote unquote good. What that means is it accurately predicts things at least 70% of the time within a certain amount of accuracy. And I don't want you to get kind of turned off on that point of accuracy or confused on that point of accuracy. We'll get into that in a few minutes. But it doesn't necessarily need to predict exact amounts of solar radiation. And the reason it doesn't need to do that is because most solar panels really aren't very efficient anyway. So even if you could get it really down to the watts per meter squared, the solar panel itself is just not a very efficient tool as of yet. So there's a lot of variance in how they actually work. If needed, this is sort of a caveat, if needed, you could also get by with knowing just a good estimate of even a range of predicted values. So you're going to find out as we work through this. That's kind of an ace in the hole card, kind of a free play in case we can't get something to work out. So 2 questions here. What's being predicted in the model? What are we being asked to find? Well, we're actually being asked to find the amount of solar energy coming from the sun, and it's called solar radiation, or GHI, global horizontal irradiance. You can see that's actually one of our columns here. So if we're using that as what we're trying to predict, what will serve as the inputs of the model? Well, all of these other things, all of these other numerical weather features and time-related features will actually serve as the inputs of the model. We generally refer to those things as features. In this particular exercise, we're going to call those X's, and we're going to call what we're trying to predict the outcome, which is an actual Y. But I'm getting into sort of the machine learning terminology of this, so I don't want to go too much further without talking a little bit about machine learning. So let's dive into that next.